Assalamualaikum. Okay, we continue with second part of copolymerization chapter. Now we look at the ideal copolymerization or the random. We call it as a random. We have two cases for random copolymerization, which are R1 equal to R2, which is equal to 1, and R1 times R2 equal to 1. For the condition of R1 equal to R2 equal to 1, under this condition, the growing radical, it cannot distinguish between the two monomer, means that K11 equal to K12 and K22 equal to K21. So this copolymer have completely random sequence of monomer units, means that the value is same, which is equal to 1. For the second case, we have R1 R2 equal to 1. It means that R1 times with R2, you will get 1. In this case, either R1 more than 1 value or R2 is less than 1. Okay, or we have a R2 value which is more than 1 and R1 which is less than 1. So in this case, one of the monomer is more reactive than the other if the value is more than 1. So this condition will have the one value which is more than 1 and one value is less than 1. Consequently, the copolymer will contain a greater proportion of the more reactive monomer in the random sequence of the monomer unit. Block N or homopolymer, the condition is if R1 and R2 are both greater than unity, then both radical would prefer to react with its monomer. So the addition of the same type of monomer would continue successively until there is a chance addition of the other type of monomer, and the sequence of this monomer is added repeatedly. So we call it as a block copolymer, which is more than 1. Condition is for the alternating copolymer when both reactivity ratio are 0, means that it is less than 1. In this case, K11 and Q22 are very small, and it means that there is no tendency for the radical to react with its own monomer. So in this copolymer, the two types of monomer units must therefore alternate along the polymer chain, leading to a completely alternating copolymer. So perfect alternation, okay, alternation copolymer will occur when both R1 and R2 are 0 value. This condition enhances the possibility of the producing polymer with appreciable amount of both monomer. So it means that it has 0 value or 0 point something, which is less than 1. And look at the sample cases based on the types of copolymer formed. Now we look at the example. For R1 value, which is 0.03, which is less than 1, where we are 2, which is less than 1, which is 0.03 also. So we can expect that if the R1 and R2 is both are less than 1, the neither monomer homopolymerize very well. So it will form almost perfectly alternating copolymer of high molecular weight. Alternating copolymerization is common in the free radical reaction when one monomer has electron withdrawing groups and the other has the electron donating group. It is often more convenient to work in terms of mole fraction. We can define F1 capital letter, which is mole fraction of monomer 1 in the polymer at some instant of time, and the small capital letter F1 is the mole fraction of monomer 1 in the feed at the same instant of time. So given with this formula, it tells the composition of polymer being formed at a given co-monomer feed. Note that in most cases, the composition of the monomer mixture changes as the reaction proceeds because one monomer is consumed faster than the other. So equation is right here, and note that this equation describes the instantaneous copolymer composition. You will meet at this point. We call it as the azeotrope, and the value for F, the small capital letter inside here is 0.5 because it it meets at the center of the point which is 0.5.